All right, so now in this video, what we're going to do is we're going to look at doing a few more of our different ways to calculate concentration. And so just continuing through the list, the next one up is mass percent. And what mass percent is it's just a measure of the mass of your solute per mass of solution. So how much of that solution is composed of your solute, multiplying it by 100 to get you to a percentage. And, all percentage really is just means percent, where per is, per, and then cent is centennial. So that's how you get, 100 here. And so in our numerator, we're going to be putting the mass of our solute. And the denominator, we're going to be putting our mass of solution in total. And then because this measurement is based on mass, both of solute and solvent, this is also going to be constant with temperature. And our unit for this calculation, or this type of concentration unit, is going to be percentage. And the reason that we use this is since it's an easy way to describe household things that we deal with in our everyday life, such as sugar and salt. Because when you're at home, if you're baking or if you're cleaning, no one's asking you to make a 1 molar solution of sugar in water for cookies or anything, or a 0.5 molar vinegar solution in order to clean something. Instead, you're saying, hey, can you make a 10% sugar solution? Which is just saying that 10% of the mass of that solution should be sugar. Or, you just got your wisdom teeth out and you have to wash your mouth. Why don't you make a 5% salt wash in order to disinfect those pockets in your gums? And so this is a very, kind of tangible way to talk about concentration. And just in terms of how we calculate it, just as we had before, and then we put down what we've talked about in our numerator and denominator, multiply it by 100, and that's how we get to these concentrations. Another type of concentration unit, and actually we're going to talk about two here, is that of parts per million and parts per billion. And this is what we typically use when we're talking about the concentration of pollutants, things that are relatively small or there's relatively little of it, but even when there's a small amount of it, we really care because it can affect our health. And so in this case, it's once again mass per solute per mass of solution. So very similar to what we did when we talked about mass percent, where we have mass of solute, mass of solution denominator. But here, instead of multiplying by 100, we're going to multiply it by different factors, where parts per million means that we're multiplying by a factor of 10 to the sixth, that being 1 million. So we have 1, 2, 3, 4, 5, 6. And parts per billion, we're multiplying by a factor, I'm just going to put multiplying here, multiplying by a factor of 10 to the ninth, that being, 1 billion. And when we talk about units, ppm means parts. So this is parts. This is per. And this is whatever the unit is, in this case, million. So we have parts per million and parts per billion. I'm just going to rewrite parts here. And so the reason that we use it, and you're going to see it's probably going to go through my per, is that it's an easy way to talk about the presence of trace chemicals in the air. And so if we're looking at an air quality index for CO2 and ozone, we might see that there's a green AQI and a yellow AQI talking about, what amount of pollutant is safe for us. And so for CO2, that might be 0 to 50 parts per million in the green zone, and for ozone, 0 to 64 parts per billion. And in the yellow region, maybe that means that we have a little bit more. So we have 51 to 100 parts per million for CO2. That's when we're in the yellow zone. We're starting to, wanting to be a little bit careful here. And then 65 to 84 parts per billion for ozone. And so kind of to elaborate on, these multiplicative factors, when we talk about 0 to 64 parts per billion, what we're saying is that there's 64 grams of ozone, so of O3, per 10 to the ninth grams of air, which is the same as saying, 64 grams O3 per 10 to the sixth kilograms of air. And so that means that if we're looking at, breathing in this type of air, if every breath is 500 milliliters of air, which just means that's 500 grams of air. Sorry, I guess I didn't account for my density. Scratch that. That is 645 grams of air. In that 645 grams of air, that would mean that we have 41 micrograms of ozone per breath, which is a very small amount, but if we exceed that, it starts to get, dangerous for our health. And if we do a similar type of what does this mean in the real world for our ppm, that means that in this yellow zone, we'd have 100 grams CO2 for every 10 to the 6th grams of air, which is the same as saying we have 1 gram of CO2 per 10 kilograms of air. Or the way you'll most often see this is you'd have 100 milligrams per kilogram. And so that's one way that we can think about ppm, is that ppm is the same as saying milligrams of solute per kilogram of solution. And then ppb would then be micrograms of solute per kilogram of solution. And so when we're looking at, CO2, in each breath of air, composed of the CO2 contribution of that is 0.0645 grams of CO2, or 64.5 milligrams of CO2. And so that's our parts per million and parts per billion. One more example that is a tangible quantity that we like to talk about is instead of mass percent, volume percent. So we're looking at, relative volumes. So we have the volume of solute per volume of solution. In the numerator, we have the volume of solute, denominator, volume of solution. And because both the numerator and denominator deal with temperature, they'll fluctuate with temperature. Sorry, they both deal with volume. They'll fluctuate with temperature separately. Our unit is V over V percent, where when we had a mass percent, that's mass over mass percent. And then you'll even see sometimes if you have a mass per volume percent, it's M over V. So just in the numerator is the type of unit we have for the numerator, and in the denominator is the type of unit we use for the denominator. And so this is another way that we can describe household chemicals such as vinegar and bleach. In this case, we could talk about having a 5% volume over volume acetic acid or vinegar solution. Or if we're needing to bleach something, maybe we'd say a 10% bleach solution. Or we're trying to clean our cuts, so we'd use a 10% hydrogen peroxide solution. And then after we use that hydrogen peroxide, maybe we want to sanitize it, so we use 70% isopropyl alcohol. So, these are actually units you've seen before in your everyday life. And so here is just that same type of description for that unit. And so what I'm going to do is I'm just going to end the video here, and then in the next video, we're just going to talk about some examples using these types of concentration units. And then we're going to talk about our final couple concentration units in a separate video, do a final little video with problem solving, and then we'll be done with all of these concentration units.